In this video, I want to cover problem 3 on page 605 in the notebook, which is an example of a differential equation, but it's one that's a little bit different from the ones that we've solved both earlier in the year and earlier on this page. Let's take a look at what's different about it. So in this case, we have that dy dx is equal to x squared plus 2x over 2y. And we also know that f of 0 is equal to 2. So this is a differential equation. We're talking about the derivative of this thing. But what's different about it? Well, we've got both x's and y's over here. So you remember earlier in the year when we were talking about taking derivatives of functions and they had both x's and y's in the derivative. Do you remember what that unit was? What we called that? That was called implicit differentiation. And the way we solved implicit differentiation is basically we kind of took the derivative of both sides of the equation. And that way we were able to, keep track of x's and y's interacting with each other. What this is this is an example where we're going to do the same basic idea, except in reverse. Instead of differentiating both sides of the equation, we're going to integrate both sides of the equation. And the first thing I'm going to do to make that happen is I'm going to cross multiply. So over here, we've got 2y dy is equal to x squared plus 2x dx. All right. And so what I was able to do when I cross multiplied there is over here, I've got a statement just in terms of y's and dy's. Over here, I've got a statement which is just in terms of x's and dx's. So this is called, because of that, this is called a separable equation, because I can separate the x's and y's onto different sides of the equal sign. And so because of that, what I'm going to do is I'm just going to integrate both sides of the equation in terms of their respective variables. All right, so what is the antiderivative of 2y with respect to y? Well, it's just y squared. So y squared, the derivative of y squared would be 2y. Remember, we're always going to talk about adding a c here. So I'm going to say c, I'm going to write a little subscript y down here, just to remind me that this is the constant with y. And over here, I'm going to do the same thing. So what's the antiderivative of this with respect to x? Once again, every step going along the same way. So that's 1/3 x squared plus x squared plus c, and I'll call that cx. All right, and so here is a relationship in terms of both x and y, and this is a relation that satisfies that differential equation. Let me do this. Let me subtract cy from both sides of the equation. So y squared is equal to 1/3 x cubed plus x squared. Now, cx is just some real number. I don't know which one it is. Cy is also a real number. Again, I don't know which one it is. So I can just combine those into a single into a single c instead of talking about both of them. And I'm just going to call it big C like we normally do. And so when we're doing this in the real world, in problems where we're not, breaking it down and instructing step by step, we really just ignore these CX's and just think if we're integrating both sides of the equation, we just need to have a big C term sitting around somewhere to make it clear that constants have a derivative of 0 and go away. So this would satisfy this equation no matter what C is, and these are the only equations that would satisfy this equation. And can we solve for C in this case? Yeah, we can. Well, maybe. We'll see, because we know that f of 0 is equal to 2. So here's our x value. and here's our y value. All right, so we've got 2 squared, so that's equal to 4, is equal to 1/3 x cubed, where x is 0, so 1/3 times 0 cubed, plus 0 squared, that's a whole lot of 0. And so we've just got c on this side of the equation. And so the overall individual solution to this equation is this relationship, that y squared is equal to 1/3 x cubed plus x squared plus 4. This is an equation that if we took the derivative of this, if we calculated y, derivative of y with respect to x using implicit differentiation, we would get this relation here. And also, if we substitute 0 in for x, we're going to get 2 as our answer. So this is the equation that satisfies that set of conditions. All right, in the next problem, we'll take a look at the next problem and see if that's basically the same thing or not.